Now we're going to turn our attention to lists. The two data structures that are most commonly used when working with complete data sets are lists and data frames. So we're going to start with lists. We often manipulate individual vectors, but when we look at an entire set of data, we often deal with data of different types, so they need to be stored in lists. The characteristics of lists are that they are objects that contain different types of elements. They can contain vectors, they can contain matrices, they can contain other lists, they can even contain functions. A list can be thought of as a vector of objects, but because those objects can be of different types, it's a non-atomic vector of objects. The class of a list is, wait for it, list. There are no default attributes to a list. Let's take a look at how to create a list. Databases and research data sets almost always contain various types of data, so lists and data frames, which are a special type of list, are the most common data structure for storing the set of data as a whole. We may take individual vectors out of the list for analysis, but knowing how to create and then access elements of a list is vitally important to using R for research. Now we can create lists by entering list data or by combining vectors. The vectors can be of different types and length. This makes lists ideal for storing output of functions, such as hypothesis testing functions, analysis of variance functions, linear models, and so on. So very often, when you use a function that's in base R or a package, what it is returning is in the form of a list. And that's good to know because it means that if you store what it returns into an object, then you don't have to use the entire object. You can subset or extract different elements of the list that are useful for your purposes. All right, let's create a list. We use the list function to create a list. Remember, a list is simply a vector of different kinds of objects. So in this particular list I'm creating here, we have 4 vectors. First, we have a single string of characters, EDRM718. Next, we have a vector of 2 strings of characters, Tuesday and Thursday. Then a vector of 3 strings of characters. Then a vector of numbers from 1 to 17. And finally, a list, which remember is itself a vector of different types of objects, and that list contains a vector of strings and a vector of numbers. So list can contain list, which can contain list, which can contain list, and so on. I'll stop there. So using the list command, we can create this list, and then let's look at it. So here is our first vector, our second, our third, our fourth, and then all of this down here is another list that itself contains 2 vectors. Now you probably noticed the square brackets and double square brackets. We'll talk about that when we talk about subsetting and extracting items from a list, and all will become clear. We can use existing vectors to create a list. So here I am creating the same vectors that you see in the list above, but I'm going to create those as vectors first. You can see here in my environment that I've created those vectors. And now I'm going to create a list using the list function with those vectors. So we have the same thing that we had before. You can name list elements with the names function. So here I'm naming each of the elements of the list. Let's take a look. So here you see now I have a title, days, activities, student IDs, and then grading is itself broken up into two vectors, grading 1 and grading 2. Grading 1 are the types of different activities that students are graded on in the class, and grading 2 has the percentage breakdown. You can also name the elements when you first create the list. So here I'm creating the list just as I did above, but notice that I'm using character strings in front of the equal sign to name each of these. So here's the same thing again, but just done a different way. The class of our course is, of course, a list. Now there are no default attributes, however, we added names. So now names become an attributes of our course. Now notice something about when I listed the attributes of our course. You saw the $ names just like you saw up here, $ title, $ days, and so forth. The attributes are themselves a list. When you use the attributes function, it returns a list. Let's look at this a little more by storing attributes of our course in an object and look at the class of our course attributes. It's a list. So for creating a list, you can use the list function. Lists can be created with new or existing vectors. And names can be added either before or after list creation. You can name each list element while entering the element, or you can use the names function on a list that already exists. Now let's talk about subsetting a list or extracting from a list. With the classes of objects we have studied up to now, subsetting and extracting was basically the same thing. But with list, as you'll see, it's different. Here is our course. If we ask for the first element of our course, we get title EDRM 718. Here's the third element. The activities. Here's the fifth element. The grading. In all three of these instances, note what is actually being returned is a subset of a list, which is also a list. That is, just like if you subset a vector, you get a vector. If you subset a list, you get a list. You don't get a vector when you subset a list, and that becomes very important. We'll see why in a moment. Here, I'm going to store our course 3, which was these activities. I'm going to store it in our activities so we can look at what it is: activities, presentations, writing scripts, and learning groups. It consists of the 3 strings of characters. Let's look at the class of our activities. It's a list. And let's look at the type of our activities. It's a list. So whenever you use one of these square brackets with a numeral in order to access an element of a list, you're getting a list. So you cannot do vector manipulation when you subset in that way. But what about instead of subsetting, we wanted to actually extract? What if we want to pull out a vector from the list? Then we can use the extraction operator, which is double square brackets. This operator will dig into the list and dig out its content. So here, I'm asking for our course 3 again, but now I'm using the extractor operator. And so when I do that, notice what we get. See the difference? Up here it said activities, and then it gave the 3-character strings. Down here, it just gives the 3-character strings. Let's look at the class of our activities. It's a character. Therefore, it's a character vector, and the type of is character. So there's an important lesson there. If you have a list of data and you want to pull out the actual vector itself of that data, rather than subsetting to another list, you have to extract rather than subset. You have to use the square brackets. Now, if the elements of the list are named, as they are for our course, let's look at it again. Each of these elements here in our course are named. If they're named, then you have another extract operator that makes it more convenient to pull out the associated vectors, and that's the $sign. So you have been using the $sign in this course, and if you've taken classes from me in the past, you've used the $sign often. Now you know more formally that what the $sign does is extracts from a list. So let's take our course activities, which we've been looking at. That's the third item in our list. Let's extract our course activities to our activities. Now you can see the class is a character, so this is a character vector, and the type of is character. You can use names if you want with the extraction operator, the original extraction operator, the double brackets. There's our course activities. Notice it actually extracted the character vector. Note the use of the extraction operator to obtain an element from our list within a list. Let's look again at our course to remind ourselves of the list within a list. Here it is right here. It's named grading, and that itself is a list, and so you have a character vector within it, and you also have, for the second item, you have a numeric vector. Look what I'm doing here. From the 5th element, I'm extracting the information in that element, which itself is a list, and so I want to extract the second vector, which is that numeric vector of grading percents. There they are. Or alternatively, since that is a named element, grading, we can say grading extract the second vector. There it is. Now that raises a question. Can we name elements of a list within a list? Yes, we can. So look what I'm doing here. I'm going to extract our course 5th list, and to that, I am going to name requirements and percents. Now let's look. Our grading requirements. We can extract grading and extract requirements, and there they are. Our course grading percents. We can extract grading and extract percents. As with vectors, we can leave off a list item. Let's look at our course again. What is the 4th item? 1, 2, 3, 4. It's this student ID list. So here it is. So now I have the list without student ID. Why doesn't this next one work? Let's try it. Our course extract, and then extract everything except 4. Why doesn't that one work? Think about it a moment. What you're really asking it to do, this might help clarify it. Remember what you get if you do our course and extract 4. You get the whole vector. So what you're saying is, I want to extract everything but 4, but wait a minute. 4 is actually what's within the 4th element of the list, so this makes absolutely no sense. But how about this one down here? What about if we extract the fourth vector and then within that vector keep off items 3 through 5? That works. Notice 1, 2, 6, 7, 8, 9, 10, and so on. Finally, we can use logicals to subset a list. So again, here's our course. And now I'm saying I want the first, the second, not the third, not the fourth, but I do want the fifth. And so what you get is a subset of a list that has the first, second, and the fifth elements. So it's important to think of the difference of subsetting, in which you're pulling out another list, and extracting, in which you're trying to dig at the vector contents within the list. We access sublist by the number of the element with the subset operator, the square brackets, but we extract content by the number of the element with the 2 square brackets, and if it's named, you can extract with the $sign. Vector rules work for extracting single elements, using sequences, leaving out with a negative sign, and using logical values, but those have to be single elements. It can't be something within a list.